Should be ready. Looks like it's going.
Well, it looks like everybody's here and raring to go. So I'd like to call this meeting of the San Diego DX Club, the August meeting, to order. We'll start off with the Pledge of Allegiance. And Danny, if you could lead us in the pledge, that would be great. Oh, he doesn't need a mic. Okay. To the flag of the United States of America, and to the republic
for which it stands,
one nation, under God, indivisible, with liberty and justice for all. This evening's meeting is Tom Schiller, and I'll have Bud Hennessy, A6BH, introduce.
All righty. Well, tonight we've got the pleasure of having Tom Schiller, N6BT, who's going to give us a talk on antennas and efficient antennas for small spaces and people who might be stuck in home owners' problems. And he's been in the business for a long time. He founded Force 12 back in the day. Now has his new antennas with the next generation that he's doing. And I think you're out in Kingman, Arizona there, right, Tom?
Now that I unmuted, yes.
Okay. Anyway, well, welcome, Tom, and we look forward to hearing about your presentation here.
Okay.
We need to hand off the control to Tom so he can pull up his presentation. Oh, okay, so he's got control.
Okay. Oh, there it is.
Turn this thing.
Okay. Why isn't it doing that? Let me try it again. There we go. Okay, everyone see that correctly?
Yep.
Yes. Okay. Well, I always appreciate Albert Einstein's wisdom. And tonight, of course, this is you folks. And I'm a little ways away. And yes, you're correct. I'm in Kingman, Arizona, up in the northwest part, where today you were mentioning the temperature. I think it was maybe we might have gotten to 100. But over the last weekend, it felt really good. It was in the low 90s. Certainly not like Phoenix that had, I think, over 100 days of 100 plus every day. So here we go. It is, you were close on the title. There's efficient antennas for limited space and time. And for example, you folks are DXers and so on, so you're very familiar with this. Limited space can also be visual, besides physical restrictions. And even if you have an HOA that's really tough and no antennas mandate, there's time. If you're doing portable things like today, a lot of parks on the air and summits on the air, you only have a certain amount of time to get to where you're going, set up, operate, and then take down and safely leave. There are always de-expeditions. I think I've done about 30 or so, mostly for contesting. And then just temporary, I put in there a sneaky HOA where you may just put the antenna up and then take it back down again. And of course, both of these aspects directly impact the most important part of our station, which is how much power we're running. We're not, just kidding, which is, of course, the antenna. Today, we see an awful lot of single wire antennas being used, such as the inverted V, old style tower, a lot of inverted L still, but the latest, of course, is the N-fed half wave and a lot of variations of that. I mean, even the ARRL sells one of their own. And I'm focusing on HF, not VHF or higher. I was asked a while back what antennas I had used before I started Force 12 back in 1991. That seems like an awful long time ago. And then which antenna stood out on the list. So I made up a list of what I could remember having used. And the ones that stood out are the ones in red and the ones in bold. And particularly these two right here were the ones that made the biggest impression on me forever. And those two antennas were this guy in the upper left of Gary, WA6VEF, now VA7RR. He and I were over in Saipan. We were going to do a multi-multi, just the two of us running 2 rigs each. And we brought along an A3S, and we had that up. And we were using some other quads. And then we got an invitation to use the TCI 611 curtains of Far East Broadcasting because they weren't going to be on the air till I think it was January or February. And he said, as long as you can hook up to them, feel free to use them. Well, that took a half a millisecond. Right. So we moved all the gear up there, including the tri-bander. And the catch was on these big curtain arrays, they're all fed with open wire. So we're operating from their main building, which also contained one of their small transmitters, 140 kilowatt output, which they also offered that we could use because it was legal from that location. But the trick was, of course, hooking into these 3 curtains. And also the operating position was so nice, all I had to do was lean back and turn a switch, and I could slew them in different directions. But I was hooking them up. Gary was hooking up radio gear, and we had the tri-bander up. Now, this place is called Marpy Cliff. I realize I'm talking about this a bit, but there is a reason. We're on a 400-foot cliff, and the A3S is sitting on a mast overlooking the cliff, aimed at Europe. And we're on 15 meters, band's dead, so we're just working away. And finally, I get one of the curtains hooked up, and Gary says, well, put it on the radio. I unplugged the tri-bander, plugged in the curtain array, and actually, Gary showed up at Visalia this last year, and he came up behind me, gave me a big bear hug, and while we were chatting, he said, you know, that experience on Saipan was the most impressive in my entire radio career. Because if you were to go in a closet, for example, shut out all the lights so you're in complete darkness, then suddenly turn on a bunch of bright LEDs, that was the difference between these two antennas. Yeah. There was one station on the band, and it was HZ1AB, and he's working a big pile of Europeans. And so I get back to work, and Gary says, call him. And I said, I don't know if we have a mic. So anyway, he found a microphone, we plugged it in. I signed my call one time, and the operator came back, and he just kind of indignantly says, who was that? Yeah. And so I gave him my call again, and then he comes back and he says, do you know what you just did? And I'm thinking, well, yeah, I signed my call.
Well, Tom, could I interrupt for just a second? Someone on Zoom is not muted, and we're hearing them. Oh, Peter, could you mute yourself? Oh, thanks. Okay, go ahead, Tom. Sorry to interrupt.
Okay, that's all right. So anyway, so then I said, no, what did I do? And he said, I was working a big pileup of Europeans, and you're off the back of my beam, and you came over the top of everybody. And I said, well, that's good. So he turns his antenna around, and we have a little chat. So we're curious, let's see what the difference is between the two antennas. Well, on the curtain array, we just about had his meter pegged at like 50/9, and the tri-bander was an S7. Well, a friend of ours over on Guam was on the air, and he had, I think, a TH7 running full power. He was also an S7. His tri-bander, I think, was at 75 feet. So we started thinking about this a little bit. Like, how can we have such a disparity between these two antennas? And it took me a really long time to kind of figure this out. But if you look at the chart here, you'll see that the curtain arrays, depending on the configuration, we actually had 3 of these. They're rated at about 20 dBi, which of course is pretty good. But then the A3S was rated at 8, which I know is a little high. I've actually measured these, and I've measured them at 2.8 over a dipole. But anyway, so as the years went by, the only antenna I ever found that matched the curtain arrays is this one that our Team Vertical really put together and used a lot from the Caribbean. The nickname is a flamethrower. It's 2 parasitic vertical arrays fed in broadside. And if you ever get a chance to run one of these, it will definitely recalibrate your mind as to what a real good antenna sounds like. Okay, but we live here in Kingman, and we are on Route 66, which is known as the Mother Road. Our local radio club is this one, the Wallapai Amateur Radio Club. WB6RER was the call sign of Andy Devine, if any of you remember him. And Route 66 on the air is actually coming up in a couple weeks. It's actually the 25th anniversary of it. And our club uses the call sign W6F. So it runs 9 days. It's really not a contest, it's a special event, but you can run fairly high rates. And by the way, this year, a little bit unique. People that like to work us on Route 66, I think we have 22 stations between Chicago and LA that are on Route 66. And if you work them all, you get a really nice certificate. But this year, there's a couple in Stockton. They're going to be using the call, I believe it's W6V. They're actually driving the entire Route 66 from LA to Chicago, stopping along the way and also operating Mobile. And we're running a rover this year, W6W. We're going to go down to Oatman, where all the donkeys are, and maybe up to Seligman. But anyway, you can run fairly high rates in this activity. So I think it was last year, Vicky, N6KLS, and I noticed there are some YLs at your meeting. She's the current president of the Young Ladies Radio League. Anyway, she was on 15, running a pretty good pileup, and her pileup looked like that on 15. And she went along for a while, and then suddenly it looked like that. And I've run enough pileups, and I said, this is odd. I usually don't see this happen until I've gone through many layers of stations. But I was watching it happen. And then she would occasionally say on the radio, this is a direct quote, can anyone, just talking to the radio, can anyone find 2 or even 1 more dB? Because then I could get your call. So the question really is Vicky right? Is that margin really only 1 or 2 dB for making it through or getting over that layer of din of stations calling? Well, yes, she is. Find 1 or 2 dB, your signal will rise above the rest. And we found this out on all of our expeditions using Team Vertical. After every one, for example, these 2 places in Jamaica where we operated many times, the team would get together and we do our own analysis. And what we discovered was something that made a big difference and allowed us to set, I think we did over 25 world records. Down here in the lower right is one of the places we operated from the Bahamas. But the key was this. The gateway, as we called it, to significantly increasing our scores was if we improved our antenna system by 2 dB. It gave us a whole nother layer of stations to work. That's a whole layer. And that's how we kept pushing the records up and setting more. So to ask the question one more time, is it really that small? Okay, brings a couple more interesting questions. Is it only station A that needs to do it or station B? Or does it really matter? In other words, is it reciprocal? Well, how can we improve our signal by 1 or 2 dB? Well, the obvious one is turn up the wick. Of course, that'll get you through the pileup most likely, but you won't hear any better. So what else can we do? Since we already looked at turning the wick up, location, if we're working from home, we probably can't do much with that. But if we're doing parks on the air, summits on the air, or some kind of other expedition, we can. But the other thing we can do at home and all the other places, of course, is select the right antenna type and the installation. Now, I almost forgot this, but my homebrew novice transmitter, I was licensed back in 59. It looked like this. Maybe some of you folks actually made these yourself. Crystal controlled. Actually, I was on, I think, 7190, but anyway, or 7090. But I had a 6AG7 oscillator, 807 final, and my antenna was the window screen of my bedroom. Now, you can't do that today because they're plastic or something, but mine wasn't. Of course, it was metal. And I made it. Sorry, got something else here. I forgot this. What was missing from my station? I eventually moved up to this, which I thought was, the top of the line. Well, what was missing from my whole station that we see every day? And by the way, the farthest I got with my window screen was Morro Bay. So it wasn't too bad. But what we're missing back in that time was called a reflected power meter. Today, they sort of look like this or in other various things. And that, of course, is to give us the perfect match. Is that really the magic improvement we're looking for instead of 1 or 2 dB? Well, maybe not. Now, back a few years ago, I did this. I wrote an article. It was in QST, and the light bulb matched to the coveted 1-to-1 must be a killer. And in a weekend in the ARRL DXCW, I worked 28 countries with that light bulb. And the article's entitled "Everything Works." If you ever want to look it up, in July of 2000. I used a balun dutifully, so it was only radiating from the light bulb. So the real question is, how did I work 28 countries? And the answer is because it's the other stations that made up the gap in the path that was due to my inefficient antenna. And there are enough stations out there. So if you have a compromised antenna, you'll work stations, and you probably hear this very often, or if you watch a lot of YouTube videos, this antenna is great. It's a great match on all bands, and gosh, I work stations. It's because there are a lot of other stations there that can hear you, even if you're using a very poor antenna like a light bulb. Well, back when we were doing Forest 12, Bob Ferrero, W6RJ, of course, a silent key now for quite a while, he decided that we should make a chart. And so he and myself and a few other fellows sat down and made this chart, which is comparing your antenna to your enjoyment of radio. And if you look at the chart, there's quite a bit of data here, but right here is a dipole in the clear. And out of 10, it'll give you about an 8 for your enjoyment of radio. I had to pick the worst antenna I could imagine. And so I picked the light bulb down here and pegged it at minus 18 dB to a dipole. But if you get up here to like plus 8, you're talking world record potential for your antenna system. But I actually did test the light bulb, and it was minus 18 to a full-size 10-meter dipole. So what antennas does it take if I want to pick up 18 dB? Well, let's do this. You could do something what Mike Lamb did back in Montana. He actually had 290-foot rotating towers. On this one, he had a stack of our trapless tri-banders, the C3s, and that came out to 11.5 dB over a dipole on 20. Or you could do what Scott does in Rochester, Minnesota, K0MD. He has a 130-foot rotating tower, and he has 3 of my really big tri-banders, the C49s, 49-foot boom, roughly the equivalent of 6 elements on 20. And that comes out to 13.6 dB over a dipole. And the bottom line is to get 18 dB with antennas at HF costs a lot. So how else can I find that much? Well, what if I were to change modes to FT8? Going back to the chart. So if I do that, if I switch from CW to FT8, well, now my signal is roughly equivalent to a dipole in the clear. And I will probably get back on the YouTube and tell you how great the light bulb is for an antenna. So it makes working stations possible, especially DX, with very compromised antennas. But this is the problem. It really can mask poor antenna performance, limit your enjoyment of radio, and there will still be a time when you're in an FT8 pileup and you would like to find 1 or 2 more dB to get through. So primary concerns here for portable, how much space do you have? Do you have any trees? And are you allowed to drive a stake in the ground? Even in the parks here in Kingman, you cannot legally, let's say, drive a stake into the ground. And a lot of parks won't let you use the trees either. The other consideration is what time of the day are you operating? So if you're planning to, get somewhere and you get there midday, you probably don't need 80 or 40 meters. Do you know what your target directions are, and are they in the clear? Whole point here is put up an antenna that's putting your energy in the right direction. Practical issues here. Are there any tables or useful structures for operating or even use? And is the area crowded? Very difficult sometimes to put things up in a park or anywhere if you have a lot of people around. And how much time do you have to operate? Because, as I mentioned earlier, if you're doing parks on the air, someone's on the air, or even an expedition like we go to the Caribbean, we plan on so many days of setup time, and then we have the contest and we have to take everything down, pack it up, and go back. Occasionally, we've had weather really come into play, and we're not able to put everything up, or at least put it up the way we would like. So the total time on your site, you take that time minus the setup time, tear down, operating time, and repacking, and hopefully you get out on time. So after you arrive at your intended site, this is more for like parks on the air. As I mentioned earlier, can you pound stakes in the ground? Has a lot to do with what antenna you're using. And always look around for safety. Look at your entry points and your exit. I always park where I can see where I need to exit and where I can watch people coming in. And generally speaking, don't stay after dark if you're alone. Okay. Back to Vicky's 15-meter pilot. Did she ever ask what stations, or the stations, what antennas they were running? And actually she did, and it was always the same. N-Fed half wave or others, single wire antenna. And of course they are popular because they're good for limited space and restrictions, pretty easy to put up. It really is a fairly old design, and it's single wire, multi-band, and low cost. So let's look at the ads and see what happens here. Mostly, they're all about the match, and only the match. But that's, I think, because it's the only measurement most everyone can make. And therefore, it's become the major assessment that you'll find usually in write-ups and so on of antennas performance. But of course, it isn't. And since you're DXers, I presume you probably know that all too well. To take a look at VU2NSB's website, he has some very good analysis on several antennas, but in this case, the N-Fed half wave, for example, and I'll just read this. He says, many amateur radio operators tend to believe that this antenna can be deployed in any way they want and it'll perform well. This is a false notion. And he also says, since it's installed in a standard, neat, inverted V configuration, is far inferior to performance than horizontal, let alone other random orientations, which could often end up performing quite poorly. But not all manufacturers or dealers say that. For example, DX Engineering sells this one, the PAC N-Fed half wave, and they actually tell you in the instructions that it performs similarly to a resonant half wave dipole on 80, radiating best broadside. And then they tell you that as the frequency goes up, it develops multiple lobes at angles closer to the line of the antenna. So they're telling you the direction is shifting. And then they reference what the match is. And hopefully the SWR will be low enough, et cetera. So if you look at an N-Fed half wave and an off-center fed dipole, basically the same antennas. What do they have in common? Well, the feed point is unbalanced in both cases. The antenna is long on the high bands. It needs some kind of counterpoise, although it's really short. And coax, the feed line, remains part of the antenna. So how can you improve it? Well, let's take a look at an end-fed half-wave drawing. All right, we all got that. How about a real installation here? So we'll set it up this way and compare it to the drawing. And the counterpoise is short enough for the highest band and long enough for the lowest band. So we can take care of that. Both have matching transformer and unknown. And of course, that means the coax is not isolated because an unknown is simply an impedance transformer. It's unbalanced to unbalanced. There's nothing to stop current from flowing on the shield of the coax feed line. So if we look at possible loss, if you don't have the right material in your unknown, you can lose up to 4 dB. That's a lot. And of course, you can lose more in your coax due to having a high VSWR, which is a good reason to put a balun on there or some other common mode choke. So power, I decided to run a test. I did this last fall. Using the reverse beacon network. I was running 20 watts. Sorry, I was running 20 CW. And using this vertical here, that's a full-size 20-meter VOR. It's a vertical open ring. This right down here is called an open ring. That's the whole counterpoise. Actually, it's set up for 3 bands. It's 20, 15, and 10. But I ran it on 20 meters at 5 watts and 50 watts. So what did I get? I transmitted for 45 seconds, and I was doing this during a CWT, so I think the skimmers were a little busy. But I had 15 spots on 5 watts. On 50 watts, I had 25, and I was able to do that just 2 minutes later. Then I did a comparison of the skimmers that heard both of them, and they all look fine except for KL7RA. I don't know why it only showed 1 dB difference, but all the rest, were reasonably close. So you increase 10 dB, that's really what you get in the real world. Single wire antennas. I mentioned your target directions. So what do the patterns look like on the various bands? Okay, maybe this is a way to get a few dB. I hope most of you are familiar with looking at patterns. We're going to be looking at the azimuth patterns, meaning from the bird's eye view, like we're flying over the top. And we'll start with a 60-foot long end-fed halfway. We'll have it 2 feet going up to 20 feet, which would be kind of a pretty practical way to do it. And I'm just taking a slice at 30 degrees. And this antenna, of course, will run 40 through 10. And the work bands in the middle, of course. So if you're on 40 meters and the antenna is aimed this way, where's your main pattern? Well, it's actually going back the other direction. So if you put this up aimed at the East Coast, thinking you'd have a good signal there, you actually have a much better signal in Hawaii. So now we'll go up to 20 meters. Now your maximum signal is actually in 3 directions. And just looking at the other bands, so the black there is 40, the blue is 20, 15 meters is kind of that green, and then we have the purple. So this is how much your pattern is changing depending on what band you're operating. And if you notice, there's really nothing that goes directly in the direction of the way the antenna is physically installed. So let's make it twice as long. And we'll raise the end to 30 feet because it's basically a horizontal antenna and it needs height. So now we're on 80 meters. The antenna again is aimed this direction. Which way is our energy going? Well, it's going back the other way, just like it did before. Now we're on 40. This pattern should look familiar. This is the same as the 20 meter when it was shorter. And if we compare the two, all that happens when we make the antenna twice as long is that we actually shift the patterns down 1 band. So the moral to this is, if you're operating like during the day, make your antenna shorter instead of longer, and it'll help you control the direction that your antenna is emitting all the energy. So let's make it an inverted V now at 30 feet. Feed it at the top center. 80 meters, we're back to the 120 footer. That looks pretty good, a nice omni pattern. 40 meters, sorry, the blue is the end-fed half wave just for a comparison. Now let's move up to 40. So not too bad, we know where the pattern's going there. End-fed half wave looked like that on 40. And we'll keep moving up. This is 20, it's kind of a toss-up. And then we'll go up higher, and you'll see the patterns get pretty crazy between the two. So if you want to change the configuration, just be aware of which way the patterns are going. But I don't know, I've had enough of looking at patterns. So thought for the day, just because it matches only means it matches. That's really all it is. So some kind of improvement. End-fed half wave. First of all, the radiator is efficient. It's copper. So it'll emit and receive energy in an efficient way. The key is, where's the energy going? Which way, what direction are we actually listening? So that depends on the height and the band and the overall length of the antenna. And of course, matching it keeps the transmitter happy, but really does nothing to improve where your energy is going. So what can we do then to get a nice uniform pattern so we know where it's going? Well, there was an article in on all bands earlier this year by Ward Silver N0AX. It's called Ground Screens, the Magic Carpet. And it looked like this. And he's talking about operating portable, and he goes through verticals, base fed, loaded horizontal dipoles, and so on. And then as you go through the article, transmitting loops, he includes that. And then he goes through and he shows you this. And this is 3 laid out rolls of galvanized chicken wire or hardware cloth. Now, if I'm going on Parks on the Air, or even more like Summits on the Air, I'm probably not going to carry that in the backpack. But nonetheless, this is the magic carpet. But the catch is, he did something different. He changed the end-fed half wave to a quarter wave vertical, because that will work in a much better way, far superior. So how about considering components that might be in our antenna that contribute to the loss, or could contribute to loss? So let's take a look at a very popular portable antenna, and we'll set it up both horizontal and vertical. We made these tests. We fly drones through antenna patterns. We've been doing this for actually 10 years. The drone in the picture there is my second drone. I crashed the first one. Then Vicky decided she would buy me another really nice new one. That's a 6 rotor. I crashed that one also. And so we now have a third one. But we fly them through antenna patterns. We go out usually about 2 wavelengths. And we use a portable spectrum analyzer and a calibrated signal source, and it's quite repeatable. So anyway, we set this very popular antenna up, first of all, on 15 meters. So we have these telescoping chrome tips here, a nice coil that's tapped, and a balun. And then we changed and made some aluminum tips. We made a fixture at the end so we could screw them in just like the telescoping ones, same length. And the question was, what was the difference that we saw in the far field flying the drone? What do you think? It was 3 dB. Now that antenna actually was probably about 3/4 full size, but we picked up 3 dB by replacing those telescoping chrome tips with aluminum. So then we set it up on 40. Now we actually had 6 people watching all this, but we set it up right according to the book. We actually called Buddy Pole and talked with them just to make sure we did it right. So we had equal height radiators. I think it was about 18 feet, just from memory. And The buddy pole, of course, has its loading coil. The antenna on the right is the one we're comparing it to. It's my Bravo design. It also is loaded, uses air core coils right there at the bottom. What else do we have? Oh, yes, we had the 31-foot copper radio. And over on the Bravo, we're using these short aluminum radials, which I call resonators. And they're also slightly loaded at the center. Both were matched. Both were sitting at 1-to-1. We tested at a difference of 2 wavelengths. We actually flew the drone through the pattern 4 times. You might ask, why did we do that? It was because the first time we did it, nobody believed what the result was. So the question is, how much difference was there between these 2 antennas? Well, the antenna difference was 12 dB. That's an awful lot. So if you notice on the buddy pole over here, it was showing at VSWR 1-to-1, and there's no impedance matching device there. So what does that mean? Well, the feed impedance should have been less than 15 ohms, which would be implying 35 ohms of loss. So if you're 30% efficient, you have a loss right there of a little over 5 dB. So compressing a lot of info here. I don't recommend using these chrome-plated telescoping elements or tips. And do not use stainless steel for a radiating element or in a coil or anything but a screw, meaning a mechanical, like a machine screw or something. Many years ago, I put up a big 3-element 40-meter beam for a fellow. It was about 300 miles away, and it was up at almost 100 feet. And I said, could you do me a favor? I needed to have a hairpin match on it, and I had this idea. So I said, do you mind if I put a stainless steel hairpin match? Just if you'd run it for a month and keep track or notes, whatever you want of what you think of it, and then I'll come back and I'll replace it with regular copper coil. Well, he called me after a week and he said the antenna is like a piece of wood. So I drove back up there, and of course the black discoloring on there is some heat. Lots of loss in this. If you make a coil out of copper with an unloaded Q of over 600, make it out of stainless, your Q drops to less than 30. We've done some other tests, really empirical testing. I hadn't really messed around too much testing the 2-meter things, but I had a mag mount 5/8 wave stainless whip, and I said, let's see what happens. So we took some regular copper braid right here and just slid it over the top. And again, we're using our calibrated signal source, which is an Elecraft XG3. And we're testing out at 3 wavelengths and our spectrum analyzer there. So when we put the braid over the whole thing, we picked up almost 2 dB. Interesting. And I said, well, let's only do half, what I called half braid over. It was almost 1.5 dB. And then I said, well, how about if we just do the bottom third? Well, it was 3/4 of a dB. Well, any of those are really good improvement. We've got a couple local guys here in the club that did this for their mobile antennas. And they said the difference is really spectacular. So if you want to improve your signal, maybe you don't really need it because of all the repeaters, but nonetheless. A few months ago, back in June, I got a nice email from Radio Dan, W7RF, and he said, my reason today for writing to let you know I've been using silver braid, tin copper, over my 102-inch whip on my pickup, inspired by your suggestion. And then he talked to his friend Dave at W8XAL, who did the same thing. Then they finally decided to just do some testing. I don't know what the exact data was, but we tested one with and without. They would just plug in one and take out the other one. And he said the field strength was noticeably higher with a braid covered whip on it. Performance was exceptional. And then he goes on to kind of give rave comments some more. Then I talked with him a little bit more. Well, if you watch the internet very much on YouTube, you'll occasionally find some new products, or quite often find new products. And I came across this one called the Big Kansas Coil, the BKG. A few pictures of it. Actually, mechanically, it's very clever. It's got a nice way here of tapping onto the coil, primarily, obviously, for like parks on the air or summits or in general portable operation. And it's all 3D printed, very clever. And it's really being marketed. This was the fellow that did the YouTube thing. You probably have seen some of his YouTube videos. And so there it is, sitting there on the asphalt. So let's take a little closer look at this thing. Well, some screenshots out of their instruction manual. Oops, excuse me. They do tell you that you get radials here, and then they tell you how to tune it. So let's take a look at some of the charts they provide. So on 20 meters, gosh, this is 17 meters. Here's 20 meters. But if you look, it's gorgeous, 1-to-1, right? The problem here on 20 is the feed impedance should be less than 12 ohms. It shouldn't be 50. And there is no impedance transformer again. On 40, same thing. Goes right down here to 1-to-1. Impedance should be less than 5 ohms for the size it is. So what is going on? So if you read some more, what it says is it's manufactured out of engineering grade. It's 3D printed using carbon fiber filled nylon material. I'm not sure why you would want to use carbon filled material for a coil core. And then the coil is made out of stainless steel wire. There you go. So in general, I don't mean to be too harsh, but if you set your mind to make the most lossy coil imaginable, this is exactly what you would do. So I decided to do some modeling. And so I made 2 loading coils using my Bravo vertical as the guinea pig. And I made a 3-inch coil, 25 turns. That's 235 inches of wire. Went through the resistivity and so on, and of copper and stainless steel, got all that, went through the equations, and it looks like that. And then I plugged it back into the modeling software. And what you end up doing, that's what the model actually looks like, and full-size vertical, and then, of course, short resonators, because that's what I'm loading. So once I plugged them in, with the copper, this is the field strength. Can't remember what ground I was using, but anyway, it came out 6.3 dBi. With the stainless steel, 2.7. So we lost 3.5 dB. I think in real life, it might even be more. Who knows? So somehow I've got that in there twice. Sorry about that. So again, remember this coil. That's where your power went. So I already commented about this, just to emphasize it one more time. Please don't do that. The coil, by the way, is rated at 100 watts digital, 50% duty cycle. Why would it be that? It's because it's going to dissipate a lot of heat. Now, if you have a truck or a car with this antenna, you have a Dodge diesel, and it has an AM antenna that looks like this. It's called a wind noise cancellation wire wrap. And of course, you get the spring steel construction. But if you have an HF mobile whip, similar to what I had suggested to Dan there, you can make your own wind noise cancellation wire wrap by putting copper wire all the way up, connected, in this case, just above your loading coil, and then run it all the way up. But what you'll have is a copper wire radiator wrap. And you will still maintain the spring steel construction, so it'll bend in the wind, or when you go underneath something and hit it, it'll still bend. And the bottom line is this is a real win-win for you. You get a much more efficient vertical and really didn't spend much money at all. So speaking of chrome telescoping antenna components, that's kind of a mouthful. One of the local guys here has got some nice test equipment, and he just got one of these new little Elecraft rigs. So, and it comes with a telescoping chrome, real pretty. whip antenna. So we were trying to get some meaningful plots, and finally Glenn said, why don't we do something that we can track? So we said, okay. So we put the telescoping one on and said, let's see where it resonates, and it was right here, the red mark, 13250. Then we replaced it with copper, and it's the green, and we got it to 13500, pretty close. And the question then was, what's the difference in length? The chrome's 45 inches and the copper's 55. So copper one's 22% longer, which implies, of course, the velocity factor of both is substantially different, probably has a lot to do with the efficiency. I caught this picture off YouTube again with a screenshot, Bill DeFranken antenna. And what does he have in his hand? He's got, I think this is the new 25-foot telescoping chrome whip, let's call it. And you can get one of those for $100. I would suggest that instead of doing that, you spend less money and get a fiberglass pole and just put copper wire on it. You'll have mechanical support, lighter weight, and it'll be a far superior antenna. Now, if you're getting coax, just be careful. Down at the bottom here, it says RG8X type. I've seen this several times, and type does not mean it's really RG8X. So be careful on the coax that you get. I tend to only buy certain brands. So we looked at places for possible loss and various patterns. So let's see what we can distill out of this and get something meaningful. So, of course, everything works. And the question is better than what? And when we look at all these patterns ad nauseum sometimes, we expect the antenna to perform like in the plots. Like we put a dipole up and it should do this. You know, the dipole is going this way. This is what we expect it to be. Is that really what we get? Well, the question is the antenna all alone? And if it isn't, what next? Well, the key is the antenna needs to be in the clear from objects and so on. And I'm sure we've all run into this at one time or other. Ward came up with a term called the standoff distance. And the question is, how far away is that? Well, if we take a look at a Yagi antenna and say, how far can we put the elements and still have the Yagi work? The answer is a quarter wavelength in free space. Well, the catch is this. It's not in 2 dimensions. It's in all 3. It's a sphere around every antenna. And so this is what goes on. When we put up the antenna and we have an object that's within the standoff distance, what does our pattern actually look like? Well, our actual antenna is the physical antenna we put up plus everything within its standoff distance. And I've seen this have an effect out to 3 or 4 wavelengths. And so we end up with what I call an alien antenna because it's a combination of a lot more than just the wire or the Yagi that we put up. So recognizing it's a two-way street, it also works on receive. And a good moral is less or fewer antennas, plural, is usually the better choice. I watched a 2+ hour video on YouTube, I think 3 times, just so I understood everything that was going on. And this gentleman is comparing his hex beam to a 60-foot long end-fed half wave on 20 meters. Well, here's what he has. Looking up at his hex beam, and here is the end-fed half wave. And here's the flying lead over to the anon. And the hex beam is up above. So I decided to model the whole thing. It takes quite a bit to find the right model for a hex beam, but you can find it. So I modeled it. He actually did not have it quite oriented properly, so I offset this a few degrees. And then I added the end-fed half wave, same height, everything like his actual installation. If you take a look at the hex beam alone, not too bad. They have a little under 4 dB gain in the high 3s, dB over a dipole, so pretty good. Small footprint. As I said, I rotated it slightly. So now if we feed the hex beam with the end fed half wave below, this is what the currents look like. And if you're familiar with these diagrams, you'll notice this right here, and that probably would raise your eyebrows a little bit because that's the current in the end fed half wave. And this is what the patterns look like. If you feed the hex beam with the end fed half wave below, the blue is without the end fed half wave. The black is with the end fed half wave right below. It really distorts the pattern. Okay, if we take a look and see what the gain is, he lost almost 2 dB, about half of the gain of the hex beam, having that end fed half wave below. So now if we feed it the end fed half wave with the hex beam, you'll see there's still a lot of current up here in the hex beam, even though there's more in the end fed half wave, of course. So what do these patterns look like? That's what the end fed half wave looks like with the hex beam right above it. And if you overlay both, you know, he's on the air trying to make antenna comparisons. And I don't know. You keep doing this, and for me, it's a toss-up. It just depends on where the station is that you're trying to listen to. So I even reoriented the hex beam at 90 degrees. It still ends up being pretty much the same distorted. It's very difficult. And the reason is because this is the bottom line. He has 2 antennas, but they actually are 1 antenna with 2 feed lines. Because they're in such close proximity, you can't feed one. I mean, you can't separate the 2 antennas. So if your goals are efficiency and a predictable pattern, ways to improve a single wire, as I mentioned, shorten it, gives you more control of the pattern. Make sure you have the right ferrite in the unon. Little counterpoise, it's very short, but make sure there is one. And if you really want the best performance, use an L match, but then of course it's a single band antenna. Make sure you have a balun to get the coax out of the circuit, and elevate the end fed half wave or dipole because it wants height. It's basically a horizontal antenna. And then figure out the best installation, put the lobes in the target area that you want. And a clue, if your unon gets hot, it's handling way too much power for its components, which means it probably does not have the right ferrite. Other options, use a quarter-wave vertical, just like Ward Silver did with the Magic Carpet. Now you can use tuned, elevated gull-wing radials or vertical open ring, shortened loaded resonators like on my Bravo design. And especially if you're doing this stuff, very useful. But use a multi-band non-trap vertical. One of the real good ones that are out there is the DX Commander. And there are several ones that we used to make. Actually, I still do make them. Or use a fixed length vertical with a good current return. If you're making inductors, make sure they're air core. So a simple vertical. You can use one for each band or set up a tuner. It'll be efficient over 1 octave, which is a halving or doubling of the frequency. And they're very high efficiency. And a vertical, of course, has a known pattern. And use terrain to good advantage. We've flown drones through verticals adjacent to sloping ground, and you can validate this with some of the newer software. If you have a vertical adjacent to sloping ground, for each degree of slope, it lowers your takeoff or launch angle 1.1 degree. And yes, you actually will have energy below the visual horizon. So simple things, quarter-wave vertical, 2 elevated quarter-wave radials. How do you do that? Well, you tune the radials just like you would a dipole. Wherever the dip is where they're resonant. And I think I can just clip through this because you've probably done this before. The other key with verticals, I mean, Team Vertical, I think over the years we've operated together, I built over 300 different verticals, but at no ground contact at all. And if you want a multi-band, use the tuner at the feed point. Or if you have a relatively short feed line, you can do it at the rig. And then, as I mentioned, adjacent to sloping ground is a really great asset. If you're going on a day expedition, of course, you can select your location, but they also have limits. And of course, you run into this one too if you're carrying everything instead of shipping. And then you have a few others here. Kenny K2KW took a team down to VP2 VMM last December for the ARRLDX contest. And Kenny gave a performance to N6BT a while back. I don't know if some of you saw that, but I'm going to snitch a few slides from it. So they're down in the British Virgin Islands here, and they have a great view. There's a reef out here, so they have very little surf, well, normally. And North America, Asia's this way, Europe's over this way. Really nice selection. South America, of course, is back over land. So what did they do? Well, they do have this beautiful clean beach, which is, of course, what Team Vertical does. There's a catch, though. It is a public beach, and there are 2 bars nearby. And apparently, a lot of people imbibe a little bit too much, and then they go walking down the beach and so on. Plus, people walk their dogs there. So the catch was you could not have any radials out there, horizontal, tubing, gull wing of any kind. Plus, all the coax had to be buried going back up to the villa. So what did we do? Kenny called and he said, what can you figure out? So I said, okay, I've been working on this prototype. I just called it a Viper, and I had one on 10 meters. So I ended up finishing it, and I built 7 and shipped it down to them. So this is what it is. It's actually a little bit longer than a quarter wave, and then it's an open ring. It goes like this. This is the full current return. And we've tested this empirically with the drone and so on, and a static test. It's within less than 1/10 of a dB of 2 full-size tuned gull wing radials. But of course, it takes up a lot less space. Feed point was very simple, and using fiberglass spreaders here, and the ring is going around that way. So as I mentioned, I sent them a 7. They were using 6. They have a 2-element parasitic back here aimed at North America, Asia. And they have the open rings up here, fiberglass base post, then a sand spike in the sand, and then of course the coax is buried. In Europe, they did the flamethrower 2x2 broadside end fire phased array. The other catch was this all went down in a golf bag carrier. So the 7 antennas plus the 4-foot fiberglass base post all had to weigh less than 30 pounds, and they weighed only 26. Antennas, including the base post, are only 3.5 pounds each. And then, as I mentioned, optimizing directivity. So looking at their chart from the British Virgin Islands, their 2x2 looked like that going to Europe. Their 2-element covered a lot of area, primarily North America and Asia. And you overlay them, and they had great coverage. To do the South America, they put up a 2-element Moxon, which was going out over ground. So the gains on their antennas, a single vertical is about 6.8 dBi over salt water. The 2 elements, almost 11, and the flamethrower is almost 16. So these are the guys. They got past the record, and they're going back this December. See if they can step it up a little bit. But maybe the ultimate limited space and time is rig in a box. If you work Ducey, this was one of their temporary test setups here in French Polynesia. Same principle as Team Vertical. Vertical's on the beach. They have 1, 2, 3 there. And what they're using is my V8 design. And if you work Jarvis, you worked that same design there. They were using the V8s, but then they made their own, a V10 taller to get on the lower bands better, and the V11, which was 45 feet long, tall. So Bravo design, just for a bit of history here, first developed back in 2010 when we were on Eleuthera, and we had really limited space and limited time. So I came up with this idea, and it's been really good ever since. So the basic design looks like this. You have the vertical there, plus for multi-band, you can put coils there, you can put in relays, you can do all kinds of things. The one that I made for the rig in a box guys is this, the DX8. The radiator is 19 feet, and the resonators are adjustable 8.5 to a little over 11 feet per side. And of course, you have the remote tuner right there. So a word of caution for everyone. Might have run into this. Just remember to watch the high voltage on your antennas. Of course, the highest is at the ends of a dipole. I've been known to set my roof on fire a couple times back years ago. And think out of the box. I kind of like that. That's a real interesting antenna there. So, future of amateur radio is the youth, like most things these days. We're all getting a little bit older, but let's keep thinking and coming up with new things. So, I appreciate your time and your attention. So, if I escape out of here, and if I say stop share, you should come back up, right?
Tom, thanks
Okay.
very much. That was a wonderful talk and very comprehensive. I'm going to pass the microphone around if you would kindly answer some questions for us. I just have
Sure.
one quick question, and that was, from what I understood, your in-fed half wave is analogous to an off-center fed dipole.
The patterns are about the same.
Huh. Boy, that's news to me because I always thought the off-center fed dipole was a superior antenna, but it's
Well, it probably is because it's more horizontal.
okay, great. Thank you.
Good quick question there, Tom. With regard to sort of sleeving these old stainless steel whips and such, I wonder if just getting them somehow plating them with copper would be similar, or plating them with nickel or stainless silver. Do some sort of electroplating process would improve, since it's a skin effect impedance anyway.
Okay, well, you're in California, so you're probably at a real big disadvantage finding a plater,
Tijuana.
especially one with a big enough bath. Uh, the real key, if you can copper plate it, you can't plate. You need to do copper cladding, and cladding is 10% of the diameter. Otherwise, the skin effect, you'll just go right through the copper and back into the stainless steel. We actually did this for real. A friend of mine had the biggest whip he could find, and we were comparing it to one of my little portable antennas that was aluminum. And I was working stations. He never heard a thing. So he got a little upset, but he went out and got it copper clad, and he flashed it with nickel. And then we were equal. So the easier way to do it actually is to take, I did this on one of my truck. I've got, I think it's a number 20 enameled wire, and I attached it at the base, ran it up the side. I took some heat shrink, and just put some heat shrink on like every foot or so, and then wrapped around the top. Same difference.
Thank you.
Yeah, KW6Q here. What difference did you find that the resonance of the radiator itself have? In other words, in my case, I've got a remote tuner into a 20-meter element, and I use it on several bands. It seems to work pretty efficiently. It's like you say, above ground as well, about 15 feet or something. So my question has to do with radiator itself. I use resonant radials, but not the radiator itself.
Okay, and the radials are above ground.
They're above ground, and they are resonant on all the bands that I tune the thing for.
Okay, that's the best way to go. Even if they're not resonant, your tuner probably can make up the difference. So if you're running let's say a single band vertical, and the whole key is the efficiency of your tuner, but having it right there at the base or at the feed point is the best place to have it.
Okay, thank you.
Great presentation, Tom. Enjoyed it.
I kind of like this camera. It follows your voice.
I'm trying.
Oh, you're doing it. Okay.
This is Steve Handrop, K6RSH. I got some questions on the vertical. I live in an antenna Nazi neighborhood, and so I've had to be creative for well over 30 years. And one of the things I did is I took, the solid copper wire that's plastic coated UV that you get at Home Depot in a roll, and I've been making verticals. I got two palm trees and one is tuned for 40 meters. And I used to talk to Boise every day on it. But you were talking about the radials, and I had some radials with the same wire, and they were elevated. But you're saying that I shouldn't ground any of the radials, which is what some of the things I've been doing. That is wrong.
Okay. Let me give you a little longer answer. If you were to make a classic quarter wave vertical, say a vertical, quarter wave vertical, and let's say, I don't know, 4 quarter wave radials, lay it on the ground. Do a field strength measurement. I mean, using calibrated stuff. Then raise that. Well, first of all, what you'll find is that if you're making it for 20 meters, it will not be resonant on 14 megs. It'll probably be resonant on 12 or a little below. That's because the ground is a big capacitor. So, of course, classically, what we would do then, we'd say, oh, the antenna is too long, so we'll shorten the vertical. Well, what will happen when I do that right now, since the radials are too long, maximum current is in the ground. Now, when I shorten the vertical some more, I'm pushing more of the current in the ground. So now if you raise that antenna up and just use 2 of those elevated radials, you will pick up about 7 dB.
Thank you. They've been actually I live on the side of a hill, so the elevated radials were going down to wooden poles that were up about 6 feet, and that was
Sounds
just
good.
so it was by convenience, not by design.
Yeah. So on my vertical open ring, the open ring, the length of an open ring is just a little bit longer than a quarter wavelength, but of course it's much smaller. So on 40, which you all the space you need is a square about 8 feet square. So I've used them. The antennas that we had, we just moved into town, so I've been disassembling a lot of stuff. But we had a 44 square. It took up 48 by 48 feet. That was all it took up. And 3 elements on 80, and then a 2-element 160. There were no radials on the ground, and on 160 we used open rings on all. So just space wise on 160, the square was only about, I think, 34 feet on a side. So, and one open ring is literally the same as 2 elevated radials. So if you want to save space, there's another way to do it. And if you want to do multi-band, you can make concentric rings. And one of the other antennas we have that we've been testing a long time is a step arc short vertical with the 80-40 meter coils. And we have an open ring below it that has 7 concentric rings. But I also have it on an actuator. So you press a button and the antenna just lays over. And you press it again and it goes back up. So if you want to be a little sly, you can also use actuators.
Well, thank you very much.
Sure.
Thank you.
Hi, this is Jim K6ZH. Oop, I guess there I am. Thanks
Okay.
very much. We've met at Visalia a number of times over the years.
Yes.
So you talked at length about stainless steel and versus copper. Question is, where does aluminum fall in that discussion?
Well, it's an awful lot better than stainless steel. It's obviously not quite as good as copper, but it's a very good alternative.
Yeah. Well, the reason I ask is because the majority of the elements on most of our antennas are aluminum. So
Right.
yeah.
No,
Okay.
it's a reasonably good radiator.
Okay. All right. Thanks.
Where's Vicky?
I think she's out for a walk, actually. Well, hang on just a second. Hang on. Vicky. Sorry, she's out for a walk.
Great presentation. I liked it. So obviously a curtain is better than a screen, right? So how big was
a little bit.
How big was the curtain?
The curtains were 240-foot towers. They have 60 dipoles stacked this way and a passive reflector. And the passive reflector, I can't remember how many wires it had in it, but give you an idea of the mass of these things. The passive reflector has a lot of wind load, and they're hooked up to a pulley system with huge concrete. I can't remember what shape they were. I think they were big circles. I don't know. They must have weighed 4 or 5 tons. And when the wind blows up on that on the cliff, they actually will rise up a little bit as the curtain flexes in the wind. and the towers, the way you climb them, you climb inside.
Wow.
Although when we were setting up the antennas, Gary said we need a 160, and we didn't have one. Well, we had a 160 dipole. So he said, "How are we going to get that up?" And I said, "I'll put it up." So I free climbed the outside. And I said, "Just yell at me when the end's off the ground." Of course, it was about midnight, so it was kind of dark. It was kind of interesting being that high up on a 400-foot cliff. Kind of gave me a different perspective. Oh no, I didn't have a safety belt either.
Oh, with the counterweights going up and down in the wind. How high off the ground is elevated?
Okay. We've made a chart years ago. So on 20 meters, it's about 18 inches. And 40 meters, it's about 3 feet. Or 4 feet. 4 feet's good. 80 meters is about 8 feet. And 160, 16 to 20. That's it.
Okay.
Not much.
Yeah, the antenna we have at our vacation house is a 4BTV and 2 radios on each band, and it's on the roof, concrete block building, so it's elevated enough, I guess.
Oh yes, that should work good.
Does work good. Anybody else?
Tom, what would be the difference between an INVIS or a NEVIS antenna as opposed to the elevated horizontal?
Well, for example, we have one here. Vicky uses to get into some of the nets. Right. It's a loaded 40-meter dipole at about 11 feet off the ground.
11 feet.
And of course, most of the energy is going pretty much straight up.
Yeah. Okay. Thank you.
Great. Well, thanks very much, Tom. That was a wonderful, comprehensive talk, and I think everyone enjoyed it.
Okay. Well, I appreciate the invitation. So if you have any other questions, seriously, send me an email. It's just tom@n6bt.com, or to the lady there, n6kls@yahoo.com.
We have a roundtable now where we go around, and if there's any closing comments, we'll start off with you. Do you have anything closing you want to say to the club?
I just appreciate the opportunity to share things with you. And let's see, I'll be at Pacificon this year again and at Visalia. So hopefully see some of you folks.
Great. Well, thanks again.
Okay.
Bob, K9RHY, anything for the group?
No comment. I thought that was a great presentation. I really enjoyed it a lot. So thanks for that.
You're welcome.
Peter, do you have anything to report?
Yes, I lived in Palos Verdes for 25 years, right down the street from the W6AM Rombic farm. And I was interested in your comments on the screen and not the screen antenna, the antenna. I operated the Rombics quite a bit. As you know, he had 16 rhombics. I'm sorry, he had eight rhombics up and in 16 directions off the front and the back. We would hear things when the band was technically closed that nobody else could hear. Now, we compared that with your Force 12 antennas, and the beam antenna pointed in the same direction was equal to the gain on the rhombics, and it could be turned. Whereas the rhombics, they were sensitive off the ends, off the directions. I just found that they were very, very interesting. And in that era, obviously it was the old press wireless station. It was just amazing what we could hear when nobody could hear it. So I know land is a problem and voices are not efficient and nobody anymore. But I just wondered if you ever had the opportunity, Tom, to visit Don's QTH and operate those.
No, I hadn't had that opportunity. I operated some other rhombics before, and then I'd also during what did we call it? Where we would do the military crossband things. I'd be at Skaggs Island. Of course, the transmitters are over in Davis,
Yeah.
and they would put me on a rhombic usually. So they are quite. I had one rhombic back in Minnesota, and it was very impressive to me too.
Yeah, they're quite an antenna, and in their its day, it was the cat's meow.
Yep.
Ron
And
W.
thank you for your presentation. It's always terrific. Always terrific to hear you.
Ron
And I
W.
enjoy seeing you, Visalia, and we'll look for you again in 2025.
Okay.
Thank you.
Ron WA6 YCU.
Okay, Ron here, WA6YOU, and
Sorry.
Fairfax City, Virginia, near Washington, D.C., where it was 105 today. Tom, fantastic presentation. I taught antennas for many years at Raytheon Corporation. I wish I'd have had this briefing years ago. Very nice. And that's about all we have. The DXpedition up at St. Paul has been booming in here. Most of us in the area have worked them on 4 or 5, 6 bands. So I hope you guys get them while they're on. CY9C, one of the members, is with the Vienna Wireless Club, where I'm a member of Vienna, Virginia, that is. And that's all I got. Back to San Diego, and we'll see you next month.
Great. Thanks very much for stopping by. Tom, it's too bad you're not here in San Diego. I'll bet you have a heck of a boneyard to build stuff from. I'll pass it around. Go ahead.
Well, we decided to move into town. I had some health issues. I had open heart surgery and some other issues with my heart. So we took down 4 towers and all those big verticals. I had to dig up 3,000 feet of buried control lines. And so right now I'm speaking to you from the house, and this is a half acre, but we got a tower ready to go up for Route 66 on the air. But I really enjoyed the other place too. So, but downsizing sometimes you got to do something. But we do have a 2,000 square foot building back here that I've been building stuff in, so can still make things for other folks.
Great. Well, you look like you're doing well after your heart surgery. I'll pass it around to the crowd now.
At least you're not in an HOA. So you've got the reign of the land there.
Yeah.
Okay.
Roundtable?
Yeah.
It's Mike, N6BT. Are you going that way? Yeah. So, mostly FT8, a little bit of SSB. We worked the Jarvis on SSB and followed the Piccolo guy on 10, 15, and 12, I think. And it's interesting. Super Fox Piccolo is interesting to hear. But it worked pretty well. And I think everybody who was contacting him enjoyed trying to track it down. Then they did go to standard FT8 for a while, but didn't catch them on the higher or lower frequency bands. So maybe next time.
Gail, K6GO, and we work the same ones because we're in the same shack. And we did have a really good time in Utah at the HamCon convention, and it was the YLRL 85th year celebration. So that was really good. And went to some really good workshops and meetings. And then we went to Bryce and Zion. That's not ham radio, but personal, and we had a blast.
It's Joan N6KIM, and haven't been doing much, but I did work Jarvis on FT8.
Jim K6ZH. I just wanted to mention that today on 6 meters, E51 EME has been on from South Cook for a while. And I was doing email and just sort of generally listening because he was being heard here and there. And then all of a sudden, this huge signal appeared, and he was there plus 10 or more for an hour and a half on 6 meters from South Cook Island today. So that was a new one for me on 6. And we worked Jarvis. So the CY9C, I have worked him, but he's really weak out here. That's why, you, WA6YO, you have a big advantage over us back there. I've heard him on 15 and 20 sideband about S.5 so far, and I'm really surprised because I've got a decent antenna system, but maybe we'll get some conditions. Anyway, if you haven't worked CY9, this is a good opportunity to do it, and probably on FT8 more so than sideband.
Mark KI6IT. I've been on the road for the past 5 weeks out of the country and some catching up and waiting for band openings, hopefully before too long.
Can I interrupt for a second? Gail, are you there?
Oh, hi, Gail. How are you?
Hey, Vicky, how you doing?
Good. I didn't realize that this was your group.
This is my group. These are my peeps.
That's your tribe.
That's my tribe. Well, good to see you. I know we're doing the round table. You have anything you want to brag about working or anything?
We're getting ready for Route 66 on the air. Did Tom talk about that?
Oh, yeah.
Yeah.
Okay, excellent. We're getting ready to put up our tower. That's did he talk about that?
Yeah, a little bit.
Okay, well, they have nothing else, Gail.
Well, I'll see you on or hear you on Ladies of the Net, maybe.
Maybe.
Okay.
All right, nice to see you all.
Great.
Thanks for the interruption there.
Thank you for the great presentation. I'm Ray, WA6NVL, and my only claim to fame is I worked all 50 states on FT8 in 2 weekends on a 20-meter dipole antenna.
Okay.
2 weekends.
Steve, K6RSH, thank you again for the presentation. And turn to our fellow over there. What was your mode on 6 meters? Was it CW or FT8? Well, I keep monitoring every once in a while, and I've had nothing for the last month.
Yeah, and I know. And today I was just so surprised. You guys were working him. I could see bouncing around, this check 5s and 7s. And then it just came out of the blue and just was solid for an hour and a half.
Oh, gee, I wish I'd known.
And what was really odd was that XE2CQ just across the border here had a hell of a time working. He finally did. But, and we're just like, 15 miles apart. So sometimes you get that knife edge propagation on 6. But yeah, he was really odd.
Well, anyway, I haven't really been doing much on HF because it's been the same old, so I haven't been able to get any new contacts, going after Falkland Islands and stuff like that. I just haven't been able to get. I've got to get a better antenna or an amplifier to get in there, I guess.
Great presentation on antennas. This is Randy, KQ6RS. Have been super busy on the air. I did work on FT8 Malawi. I had to relook up where it was in Africa, but that was pretty rare. And quite a few Costa Rica. I've been just having fun, just doing some rag chews on sideband. Kind of love doing that too. Still tinkering with the balloons a lot. did some maintenance on a balloon repeater site we have up on Toro Peak. We're making another box for someone who's going to put up in Utah. So the school semester starting, so that Amateur Radio Club at Mount Carmel High School will be doing our mentoring every week with that club. So lots of fun stuff, getting some new young people getting their technician licenses.
Good deal.
Who he is.
Oh, so one of the projects we've launched balloons with them, some long duration types that use 20 meters whisper. We had a period of time before 2020 where the balloons kept failing. We had a bunch of defective ones, so we started putting buoys in the ocean that use 20 meters whisper. Launched one in November, thanks to the Scripps Institution of Oceanography. They dropped it in the water about 400 miles kind of west of the coast. It still works. It's now, maybe 1,500 miles to the west of Hawaii, maybe a bit south of it. So every day it's updating. So it's solar powered, so it's going to keep working until something breaks. But yeah, every day people will pick up the signal. So at 0.01 watts, so 1/100th of a watt or 10 milliwatts. It doesn't take much power on whisper because you're, I don't know what, sending 13 characters over a minute, 50 seconds. So a lot of, is it energy per bit per noise kind of thing. So.
Yeah, we have a couple of guys in our group, or maybe 4 or 5, and they've launched several balloons. Our best one did almost 14 circumnavigations. It was at 50,000 feet, and then it finally disappeared.
Yeah, but my understanding is they'll get caught in a thunderstorm and get elevated too high, and then the pressure differential across the balloon will destroy them.
Yeah, the balloons they use, they talk about the only good ones are they're in Japan, but you have to buy like 10 of them. But they seem to last.
Yeah, popular one of Yokohama balloons in Japan. People are having. There's one that I know of. It's been up like a year and a half. Yeah, they go through the stretching process, and I've launched a couple. I've got one the last 4 months back, like a year ago. But yeah, instead of the expensive scientific ones, you get these commercial ones for, I don't know, $15 a piece, and you test them and you stretch them in a humid room, and there's this whole protocol on how do you prepare them.
Right.
But you do that, and they've had good success with them. So.
Well, the latest thing they're trying to do is get a video camera to do some real time, aerial shots as it's going over. But
yeah, I guess you need a different transfer. I mean, the payloads on those are like 15 grams.
Right, that's the catch.
Yeah, because it has to be powered with teeny solar cells. I don't think
Yes.
batteries work at those temperatures.
No.
So yeah, it's usually like a 17-foot length of really skinny wire, your payload, and another 17 feet. That's your vertical half-wave dipole on 20 meters.
Yeah.
So fun stuff. Yeah.
Yes, it is.
All right, I'm also Randy, KI6DGU, just a couple miles away from this Randy here in Rancho Penasquitos. I'm mostly active on 40 meters in the morning. We have a Gordo net, California Rescue Communication net on 7250 Monday through Friday. And Tom, thank you very much for the presentation there from Kingman. We have a couple of members on the Gordo net who live in Kingman. So they check in pretty often. And this is the one meeting a year I can attend. I play in a community band, and we rehearse every Wednesday night except in August. And so this is the one meeting I get to attend. I cherish the moment. Thanks a lot.
Well, I appreciate your being here.
Thanks, Randy. I'm Danny, WB6 FWS. Really nothing to report. Life is good.
I'm Brian, Can6MJK. Just doing a little FT8, little sideband. Mostly my sideband is 40 and 80 meters. So much of it's local. So been having fun with that. Nothing unique on FT8. Just got the UN for the second time, and they still haven't uploaded it into Logbook of the World. So that's one of my countries on wait. Yeah. I did one. Yeah, I did one last year, and they haven't upgraded. I just did one here a couple weeks ago, and it's still showing blank. Oh yeah. It's up. Yeah. Oh, all right, Chuck.
Good evening. I'm Chuck Wood, WD6APP. This is my first meeting, and I think I'm going to join up. Looks like a good club.
You gotta be here for 2 minutes.
I've heard they have real good speakers.
Well, Tom, you're going to start getting your cards from somebody else because I'm going to give up the B segment.
Really?
My health is failing and I need to give it up. Maybe I can give it to Bud. He's a B. But no, I worked 2 new ones, and people have been out there for years. I tried to work them. 4U1 UN. It's the first time I've ever and I got a confirmation. I worked him yesterday and got a confirmation today.
Wow.
And the one Randy said he worked, not Molly, but the other one. And they've already replied on LOTW. So that's the end of that. And Tom, I've
Okay.
had 2 open heart surgeries, so I know where you're at.
Yeah, Donald N6BTF, I really don't have anything to report. So your turn.
Yeah, Tom W0NI, nothing to report this month. Lou?
Okay.
Hi, Tom. KW6Q Lou. I had just a couple further questions. One is when you talked about the curtain, are you talking about a bobtail curtain? Is that the design of the curtain you're talking about, or something different?
No, the TCI 611 curtains are different. They have phased dipoles in the center with a big passive reflector.
Okay, so very different design.
Yes.
The second thing is I don't know if they're still in existence, but back in the 80s they used a butternut vertical on the roof with radials, and it really worked pretty darn well. Are they still in existence? Do you know? Are they?
I think they are.
Okay. And related question is about the radials. In an elevated vertical, do adding extra radials help?
No.
Okay, that's what I thought.
Not so you'd notice. Let's put it that way.
Terrific design, a terrific presentation. Thank you.
Thanks.
Yeah, I wanted to echo that tremendous presentation, Tom. I think that butternut got swept up in MFJ. I'm not sure, but I think they did. But
right now, MFJ's
I had one. Yeah, it was a great antenna. Anyway, I worked Jarvis and about 4 or 5 bands, and now St. Paul on 1 band, and I had, I got in the end of that E51 EME, and he sent me my signal report, and I went to send to him, and it died. Never completed the QSO. So maybe tomorrow. Yeah.
Hi, Tom. Bud here, E6BH, and nice talking with you yesterday. And let's see, this got back from vacation from back Utah and all that just in time for the Jarvis, and managed to get them on, I don't know, 5, 6 bands, and having fun this last couple of days with the St. Paul Island. So I had a quick question for you, Tom. I've got an old high gain 18 AVT vertical out in the backyard. It's been there for years and years. Works great. It's nice to flip to it occasionally, just to see if a different takeoff angle gets me something that I'm not getting, and sometimes that works. But your talk of elevating kind of got me intrigued here. And I'm thinking, what if I pop that thing up off the ground 6-8 feet on some fiberglass and go to elevated radials instead of the wires laying on the ground? Would that sounds like a fun experiment, if nothing else?
I think you'd be happier.
Yeah. Okay.
Yes.
Sounds like a fun something to work into the fun for the next couple of weeks when it cools down. It cools down a bit. Thanks again for the great presentation. It was wonderful.
Oh, sure.
Hi, I'm Tom K7YMG, and trying to work more CW. I've got like 5 countries to go on DXCC, and if I could ever hear anybody on CW, it would be a wonder. So I have to wait until the contest shows up, and then I can actually hear somebody. But it's been kind of fun getting back into it. I used to operate CW a lot, but I found out I can't send worth a shit, so I built myself a Morse code keyboard now. It's great. All right. Well, anyway, yeah, just doing the normal FT8 stuff.
Good.
I just had one quick comment about CW, being that Tom had brought that up. I noticed on Jarvis, it was a lot easier to work them on CW than on the FT8 Super Fox. So that's just a point. I mean, on Super Fox, I was working 50, 60 watts, and on CW, I was working 100 watts, and I got them on 10 meters and whatnot, and on CW. So it was a lot easier on CW.
There were probably only three guys calling on CW.
That could be the factor. Everybody was on FT8 and nobody was on CW. Anyway, we have a couple of housekeeping items for the club tonight. One is
Sure.
we wanted to make sure that everyone saw the report from the ARRL about settling their ransomware for $1 million. And I don't want to belabor the point, but it's all over the internet. It's on the ARRL site and elsewhere. So everyone should read that. I also got a request from Rob K6RJF regarding the Yuma HamCon coming up in February. And he had asked if any of the clubs would be interested in helping out. And being that we're a specialty club, a DX club, the requests were two options. One is to help with setting up the dinner food service and serving food on Saturday night. And the other was for crowd control. I took this to the board, and I didn't think that our club should really be involved in either of those. But if anyone individually would like to do that, you should contact Rob K6RJF. And that's for Yuma in February 21 and 22 of 2025. With that, I'm going to turn it over to Brian for the. Oh. First meeting. Oh, yeah.
I'm a retired captain for the San Diego County Sheriff's Department. And I used to be his supervisor. And he ended up being my supervisor. I'm not sure about that.
I don't. You were too much pain in the ass.
I spent 40 years in the San Diego County Sheriff's Department. And let's see, I've been a long time ham. I'm an extra class operator, and I'm proud to say that I passed the code test. WD6APP, and it's the only call I've ever had. And let's see what else about me. I actually, I'm kind of a VHF guy, and I'm thinking about getting into HF. And to be honest with you, I thought this was all just the hunting contesting that you guys did, and I don't want to do that. I want to do some talking on HF. So. Yeah. 16 years. So anyhow, I've got several friends in here. Him, and him. We won 3 years ago. He won a 7610 at Yuma. It's still in the box. I haven't even opened it up. They could have put rocks in it for all I know. But it's nice to meet all you people.
I don't need the mic, but I think we're done with it. Are you gonna close the meeting then? This what we're gonna do next is the door prizes, and so we'll probably close the recording for that.
Yeah, I need that, you said. Thanks very much, everyone, for coming.
Chapter 9 is some of the usual stuff. As usual, we have some pretzel sticks, salted, probably not good for you. We have some German beer, a full 6-pack. We have it's unruly